Now another formula, a stone sewer is there. So stone sewer of 30 centimeter in diameter and the land of the gradient of 1 by 100 using the Manning's formula. You have to use the Manning's formula. So Manning's constant n is equal to 0.013. So calculate the velocity discharge and choose this coefficient when the sewer is running full. So sewer is running full. So consider this is the circular section. So completely fully it has been filled. So sewer is running fully. Sewer fully it has been running. So when it is been running fully, radius mean hydraulic gradient, so that is R. Okay, mean hydraulic gradient is equal to d by 4. So you remember this formula. Whenever the sewer is running fully, R mean hydraulic gradient, R is equal to d by 4. Okay. So as soon as you read this sentence, you have to remember this. Okay. What you do is write the formula, Manning's formula. Manning's formula is equal to V is equal to 1 by n r to power of 2 by 3 s to power of 1 by 2. Okay, r to power of 2 by 3 s to power of 1 by 2, where r is mean hydraulic gradient, s is slope. I told whenever it is running full, you have to take this mean hydraulic gradient, r is equal to d by 4. So diameter, they only set it as 30 centimeter. Convert that centimeter into meter. So finally you will get it as 30 centimeter, and if you convert that into meter, so that will be 0.3. So write 0.3 divided by 4. Okay, 0.3 divided by 4, you will get it as mean hydraulic gradient as 0.075. So after finding this mean hydraulic gradient, then what you do is substitute the value of R. Okay, R. Okay, after R, substituting the value of the R in the Manning's formula. Okay, yes, already you know, because they only given as 1 by 100. So there is nothing else. Just you find out the velocity of the flow. So mean hydraulic gradient is 0.075. Substitute it as 0.075. Yes, as 1 by 100. So 1 in 100 they only given. Substitute that 1 in 100 in yes. So finally this will be, after substituting the value of the velocity, you will get it as 1.368 meter per second. Okay, so after finding that, the q value, what is that q value? Discharge value. Discharge is equal to, I told it's a q is equal to v into area. Velocity you already determined. Area area you have to be determined, or whether they only given, you check it and substitute the values and find out the discharge. Okay. So what is that? Area is not given, so instead of that they are given diameter. So what you have to do is velocity, you in place of velocity you write it as 1.368 area. What is the area? Area is equal to, this is a circular section, so take pi d square divided by 4. Okay, what is that? Area of a circular section is pi square. Okay, so that area in it is been written here, pi d square divided by 4. Whatever the velocity is here, so that velocity is been written here. So finally discharge will be this one. So that will be in metric cube per second. You can write metric cube per second or cubics, both are same. Okay, metric cube per second or cubic, so both are same. Okay. So after finding the discharge, you want to find out the Chassis coefficient constant. Chassis constant you have to determine. So Chassis formula, you write it v is equal to c into root of square root of r into s. So where v is the velocity, c is the Chassis constant. Okay, r is the mean hydraulic gradient, s is a slope. After finding the velocity and mean hydraulic gradient, you can find out easily the Chassis constant c. So s is given, slope value is given, substitute all the values. Okay, see velocity, it has been determined, that is velocity is 1.368. you write it as velocity as 1.368. The mean hydraulic gradient, that is 0.075. So 0.075, that is R value, it is been written here. Yes, they only given 1 by 100 in the question, substituted. So you can find out easily as C as 50. So how to do that substitution means, so first whatever this value is 0.7075 divided by 100, you do it. After dividing that, you do the square root, whatever the answer you get it, so that answer you send to denominator. So 1.368 divided by whatever the answer you got it, if you do that, you will get C value as 50. Okay, so this is how you have to do this problem. Okay, so very simple problem. One, you have to remember his Manning's formula. You have to remember only the Manning formula. You will confuse with this power only, R and S. R is 2 by 3, R is 2 by 3, S is 1 by 2. Okay, so after remembering the Manning's formula, then you have to remember the Chess's formulas. V is equal to C into root of RS. Okay, so after remembering these two, another important thing is, one, it is flowing fully. So where it has been said, land gradient when the sewer running full here. See here, when calculate the velocity discharge and Chess's coefficient when the sewer is running full. Whenever here, when sewer is running fully, they have mentioned very clearly. When they ever give that fully means, just simply write this formula, R is equal to D divided by 4. So that is R is mean hydraulic gradient. R is mean hydraulic gradient. D is the diameter of the pipe. Okay, D divided by 4. That's all. So keep this in mind and solve all the rest of the problems.